The life and death of stars. In our universe, there are billions upon billions of galaxies, with each containing billions upon billions of stars. Every star starts out as a high-density cloud of gases, known as a nebula. As the gases and dust condense within the nebula, it begins contracting under its own gravity, in a process known as gravitational contraction. The condensing matter begins to heat up and glow, forming a protostar. If the protostar contains enough matter to reach 10 million degrees Kelvin in the core, the hydrogen will begin to fuse into helium through nuclear fusion. This process is known as a proton-proton chain reaction. As the star releases nuclear energy, the outward explosive pressure counteracts the inward gravitational pressure and stabilizes the star. The protostar has now become a main sequence star. From here, the star will go through one of two slightly different life cycles, depending on the mass of the star. Small main sequence stars, the star around the same mass as our Sun, will continue to fuse hydrogen into helium for about 10 billion years until the hydrogen is fused entirely. The helium core will contract further, and reactions will begin to occur in a shell outside the core. As the core becomes hot enough for helium to fuse into carbon, the shell expands, cools, and dims to form a red giant star. Once the helium core is fused entirely, the outer layers drift away from the core as a gaseous shell known as a planetary nebula. From here, the core cools and dims to form a white dwarf star. The remaining core contains about 80% of the mass of the original star. When the star stops shining, it has become a black dwarf star. This marks the death of a small main sequence star. After a massive protostar enters its main sequence star stage, it fuses all of its hydrogen into helium in just millions of years, unlike small main sequence stars, which take billions of years. With its helium core surrounded by a shell of cooling, expanding gas, the massive star dims and expands to become a red supergiant star. Different elements begin to fuse in the shell surrounding the star's iron core over millions of years. In less than a second, the core collapses and ejects the outer layers of the star in a massive explosion known as a supernova. If the core survives the explosion and is about 1.5 to 3 solar masses, it may contract to form a tiny, very dense neutron star. If the core is greater than about 8 solar masses, it may contract to form a black hole. This marks the death of a massive main sequence star.